Hello, welcome again. We are solving some conventional questions of strength of material. The topic is bending stresses. Question number 7 from Engineering Services Conventional Examination 2009 is a cantilever of circular solid cross section is fixed at one end and carries a concentrated load P at the free end. The diameter at the free end is 200 mm and increases uniformly to 400 mm at the fixed end, 2 meters. At what distance from the free end will the bending stresses in the cantilever be maximum? Also calculate the value of maximum bending stress if the concentrated load P is equal to 30 kilonewton. Okay, so this is your cantilever and here the diameter is 400 mm as it is decreasing uniformly to 200 mm in a 2 meter length. So this is the 2 meter length and a load of 30 kilometer is load applied at the free end. So P is your 30 kilometer. So now let us take the diameter at a distance x from the free end. Okay, suppose the diameter is d. Okay, and if we draw a line here, okay, then this will be your 400 minus 200 by 2, and this will be your d minus 200 by 2, and from the similar triangle we can have 400 minus 200 by 2, that dimension, and d minus 200 by 2, that dimension, divided by 2 here, 2000 here, and x here. Okay, so we can find out d in terms of x. So then d will come out as 200 plus 0.1 x. Okay, so now we have d in terms of x. Okay, so now moment of inertia at this section, moment about x-axis is pi by 64 d4 and d is this quantity. Okay, so d we can put this 200 plus 0.1 x is first phase. Okay, and bending moment at this section is p into x. Okay, and y y is your d by 2. So in bending equation, that is the bending equation, mx by ixx plus sigma by is equal to sigma by y, and y is your d by 2. Ix is this quantity and mx is this quantity. We can put this. So p into x, pi by 64 d4, and d by 2, or we can have sigma is equal to, in terms of d we have 32 px divided by pi dq. Now we can put the value of d. We can use this, and or we can use this also. Okay, now we can put the value of d. So that is your 0.1 x plus 200. Okay, so this will, so sigma will be your 32 px divided by pi bracket 200 plus 0.1 x bracket close q. Okay, so this is the expression for bending stress at any section at a distance x from free end. Okay, so in this we can see that area is increasing in the direction. Okay, or we can say the area is decreasing in the direction, and bending moment is increasing in the direction. So to take the combination of uh, increasing bending moment and decreasing area, we have to find out the location of the point where the maximum stress will occur. Okay, because if it is of uniform section, then the maximum bending moment will occur here, and as the cross section uniform, then the bending stress will also occur here. But as the area is decreasing, so the location of the maximum bending stress will change. Okay, we have to find out this location. Now we have found out the general expression for sigma. So if we differentiate it with respect to x, and then we can find out the maxima point. Okay, so now differentiating this respect to x using divide rule. So this quantity is constant, so it will we are keeping it same. And so in divide rule, this is this will be a 200 plus 0.1 x cube square. So it will be 200 plus 0.1 x 6. Okay, and now we'll keep this term same, so that is 200 plus 0.1 x cube, and differentiate it, this will be 1. Now we'll keep x same, so x is same and differentiate it, so it will be 3 bracket 200 plus 0.1 x whole square and its differential is 0.1. Okay, now you can put it equal to 0. Okay, so so this is equal to 0. So now from this, if we multiply this, then this will be 0 and this will be this we can take here also. So now from these two terms, 200 plus 0.1 x square is a common. Okay, so then the other term is 200 plus 0.1 x minus 3 into 0.1 x. Okay, now if we put 0 negative, so that is not possible, so we'll keep the will take equal to 0, so that is 200 plus 0.1 x minus 3 into 0.1 x, or x will be a 1000 mm. So now x is 1000 mm and then the expression for sigma is this. So if we put x equal to 1000 mm and p is equal to 30 kN, we can find out the bending stress. So that is here 11.317 Newton per mm square. So that is the maximum bending stress.